In this video, we're going to apply L'Hopital's rule to find the limit of an indeterminate form produced by a difference. So the first thing we're going to do is we're going to determine whether or not this limit as x approaches 0 of this function is indeterminate. If I plug in 0, I end up with e to the 0, which is 1. 8 minus 8 is 0, so I have 4 divided by 0. But remember, we're approaching 0. So we're going to be just above 0. So this is really like an infinite thing. We have 4 divided by a really small number here. So this is going to be infinity minus, and the same thing applies here. I plug something in close to 0, and when I plug something in very small, I get 2 divided by a small number, which is infinity minus infinity, which is indeterminate. Now before I apply L'Hopital's rule, let's simplify this equation by factoring 8 out. So we're going to say that the limit as x approaches 0 for this function, actually I'm going to factor a 4 out. I'm going to have 4 over 4 e to the x minus 2e to the x minus 2. And then minus, if I cancel the 2's here, I get 1 over 2x. So these 4's will cancel, and I'm left with 1 over 2e to the x minus 2 minus 1 over 2x. And I'm just doing that so that when I go to actually combine these fractions together, it's a little simpler process. So I need to combine these together using a common denominator. So I'm going to say limit as x approaches 0, and I'm going to multiply this fraction by 2x over 2x. So I have 2x times 1 on top over 2x times 2e to the x minus 2. I'm going to multiply this fraction by 2e to the x minus 2 over 2e to the x minus 2. So I have 2e to the x minus 2 in the numerator over 2x times 2e to the x minus 2. Let's combine those together. When I combine those together, I end up with 2x minus 2e to the x plus 2 when I distribute that negative to each term, divided by, in the numerator I have, in the denominator I have 2e to the x, 2x, 2e to the x minus 2. Alrighty. Let's factor a 2 out of the denominators. I'm going to factor a 2 out of this and factor a 2 out of all those numbers. So I'm going to write this as limit as x approaches 0. That's 2x minus e to the x plus 1 divided by, I can take this, essentially I can just divide this 2 out right here. So I can write this as 2 times x times 2e to the x minus 2. The 2's cancel there, so I get limit as x approaches 0. Okay, cancel those 2's, I get x minus e to the x plus 1. And I'm going to apply L'Hopital's rule to this, so I'm going to take the derivative of the top over that 2 canceled, so I'm going to take the derivative of the bottom, which is x times 2e to the x minus 2. When I take the derivative of the top, I get limit, x approaches 0. I get 1, derivative of x is 1, minus e to the x, because the derivative of e to the x is itself, and the derivative of a constant is 0. Now this piece I have a product rule, so I have x, let's go u is equal to x, u prime is equal to 1, v is equal to 2e to the x minus 2, and v prime would be just 2e to the x. When I take the derivative of the constant is 0, derivative of e to the x stays the same. So u prime times v, I would end up with 2e to the x minus 2 and then I'm going to be adding 2x e to the x. So I can rewrite this as limit as x approaches 0 of 1 minus e to the x over 2e to the x minus 2 plus 2x e to the x. Now let's evaluate this. If I plug 0 in here, I get e to the 0, which is 1. So the top would give me 0. So I'm just going to write this as 0 over, plug 0 in here, I get 2 minus 2, which is 0. Plug in 0 on this one, and I would get 0 there. So I have this thing that's still indeterminate. So what I'm going to do is I'm going to take the derivative of the top and the bottom again. So we're going to say that the limit as x approaches 0, we're going to do the derivative of the top divided by the derivative of the denominator, which is 2e to the x minus 2 plus 2x e to the x. Derivative of the denominator, or the numerator, would be negative e to the x over derivative of the denominator. So I can actually do the derivative of 2e to the x here. That would just be itself 2e to the x. The minus 2 goes away because derivative of this constant would be 0. I have to do a chain rule, or not a chain rule, a product rule on this 2x e to the x. So I'm going to have u equals 2x, u prime is 2, v is e to the x, and v prime is still e to the x. So I end up with 2e to the x, so we're going to say plus 2e to the x, and then I have still 2x e to the x, so plus 2x e to the x. Okay, now I want to evaluate this limit. So the limit as x approaches 0 for e to the x, negative e to the x, over 2e to the x plus 2e to the x plus 2x e to the x is going to equal, plug in 0 here, I end up with negative 1, over, plug in 0 here, I get 2, 0 here, I get 2, so I have 2 plus 2, and then that would just give you 0, so plus 0, so I get negative 1/4. So I can say that this is my function, f of x, and I can rewrite this as the limit as x approaches 0 for f of x is equal to negative 1/4. And that's how you apply L'Hopital's rule.